we are worried about chapter P. We're gonna have a test. But first, we have to finish talking about this projectile motion stuff. So, for parts A and B, we did parts A and B yesterday, and wasn't our equation, trying to remember, is this right? Is this the equation we had for parts A and B? Remember in your general formula, which I will always give you, I will always, always, always give you this. Before you can do the problem, you have to plug in this value and this value. Those are the initial velocity and the initial height. Those will be in the question, and you plug those in, and then that makes your problem unique to this situation. That's the general formula. I can't remember yesterday if I did this or not, but Quinn, if you need more time, you can have it. If we talked about yesterday that S of t is the same as f of x, and that's the same as y, we were allowed to change that to y. So since this variable right here represents the height of the object, I'm going to go ahead and let it be an h. That might be easier for us to see that there are two variables in the problem. There's an h for height, and there's a t for time. Every question will give you one of those numbers. So when I read question C, it gives me 1 second. So the number 1 is going to go into this equation somewhere. How high is it after 1 second? Will the 1 go in here, or will the 1 go in here?
T squared.
It's got to go in the t, because what's the label on that 1? Doesn't it say 1 second? So that makes it time. If it had said 1 foot, then it would go in for h, because foot is a distance or a height, right? Okay, so here we go. I'm going to put 1 in for all of the t's. All of the t's. Now, you'll have a calculator for this problem, so if you need to type that in on your calculator, you can. I'm hopeful that most of you don't need to. What's 1 squared? Times negative 16. Negatives, not negative 1, negative 16. What's 18 times 1? 18. All right, so now we add. What's negative 16 and 18? 2 plus 12? 14. So how high is the ball above the ground? 14 feet. If you do decide that you absolutely have to type that in on your calculator, please type it exactly the way I wrote it. If you type it exactly the way I wrote it, with the parentheses, with everything just like that, you'll get the right answer. If you start free, whatever they call it, going rogue on it, you may not end up with the right answer even though you're using your calculator. So type it in exactly the way I wrote it right there, or just kind of do it. Since those are 1s, that's easy. Okay, one more. Read the question. Again, it's a 3-parter, so we're going to get plenty of practice here. It's a 3-parter. The rock is thrown from ground level with an initial velocity of 32 feet per second. We need to fill in, before we can start the problem, we need to put a number here and a number here. So somewhere in that sentence, thrown from ground level with an initial velocity of 32 feet per second, you need to be able to fill these in. So does anybody have a thought on either one of them?
It'll be 32 and 0 or 1.
This is going to be 32t because the initial velocity, V, is 32.
Mm-hmm.
And then Scout says this is plus 0. Why is that plus 0?
Because you're starting.
Because it's on the ground. And if it's on the ground, what is its initial height? 0. Now it's going to go up, right? It's going to get a height. But right now it has no height. And this is the starting height. This is the beginning height. Initial height, 0, because the ball's on the ground. Okay, so does that equation make sense to you? Do I need to have the plus 0 on the end? No. So if that bothers you, take it off. If it doesn't bother you, leave it on. It doesn't make any difference. That's the equation we're gonna use for all this problem, this whole problem. So what does A say? When will the ball hit the ground? Well, somehow we have to either fill in a number for H or a number for T. And they didn't give me a number. When will the ball hit the ground? That's all words, no numbers. Does it seem to you like I'm trying to find T? When will the ball hit the ground? I'm trying to find T. That means somewhere in there, there's an H. Now, when will the ball hit the ground? If it's on the ground, how high is it? 0. So I'm gonna put a 0 right here. Now, I know what some of you are thinking. You're thinking, Mrs. Ford, wait a minute. Didn't it start at 0? It did. But if it starts at 0 and I throw it up, isn't it eventually also going to come back down and be 0 again? And that's the one I'm looking for when it lands. So 0 equals negative 16t squared plus 32t. Now when we did this one with the other problem, and when we just finished the other things yesterday, we used the quadratic formula. Is this a quadratic equation? Whoa.
Yes.
Yes.
Yes,
You
it
just have
is.
to.
And it might look different to you because I didn't write the 0 here. But what does that mean? A is negative 16, B is 32, and C is 0. So since you're sitting there with a calculator, could you type all that in, at negative B plus or minus, type it in and get an answer? You can, and some of you are already doing that. I want to point something out to you though. When you have no C value, when this is all you really have, essentially, I'm going to factor out my GCF. Is there a GCF in this problem? Remember, I don't have a C to worry about, so I'm only looking at these two. Is there a GCF? And what is it? I heard 8, I think it's actually 16. And T? So I'm gonna go ahead, you do not have to do this. We already talked about you can do the quadratic formula if you want. But in this problem, because there's no C, I can take out a negative 16t, and that will leave me with t minus 2. So I took out my negative, that changes this one to a negative. Took out a t, so I have one t left here and no t's left there. And then I can say, okay, that means either this is 0 or this is 0. Once I factor, I set them equal to 0. So dividing by negative 16, t is 0, or t is 2. Now look, isn't the ball on the ground at time 0? Didn't I know that was going to happen? When else is the ball on the ground? At time 2. So when is the ball on the ground? After 2 seconds. That's when it lands on the ground. If you did the quadratic formula and you said t equals negative b plus or minus the square root of b squared minus 4ac all over 2a, notice that this is all going to go away. And it's going to reduce and simplify and come down to these two answers. You are welcome to do that. If this factoring bugs you, you're like, oh my gosh, what she did, go ahead and use the quadratic formula. And you will get the same answers. Factoring is always faster. I'm just telling you that. It's always faster, more efficient. But can't do it, you can't do it. So you're gonna use your quadratic formula. So when is the ball on the ground? 2 seconds. We've had 2 problems, the only 2 we've done so far, that said when is the ball on the ground? The last one started that way and this one started that way. So how do we find out when the ball's on the ground? We let H be 0. All right, the next one says, how high will it be after 1/2 second? So remember, the thing in the box is my formula for this problem. This is the general formula, but I put my numbers in. This is the formula I'm using for A, B, and C. So B says, how high will it be after 1/2 second? Well, now wait a second. They gave me a number, 1/2. Is the 1/2 going in for a height, or is the 1/2 going in for a time? Because it's 1/2 a second, right? Seconds are time. So H equals -16 times 1/2 squared plus 32 times 1/2. If you are choosing to type that into your calculator, make sure you're typing it exactly the way that I wrote it. As long as you do that, it will come out. It'll be fine. But you're gonna type it in exactly the way I wrote it. I'm gonna go ahead and do it in my head. Miss Ford, how can you do that in your head? Well, what's 1/2 times 1/2? 1/4. What's 16 times 1/4? 4, but it'll be negative. What's 32 times 1/2? 16. What's -4 plus 16? 12. So those of you that type this into your calculator better get 12. What's the unit on that 12? How high is the ball after 1/2 second? Feet. 12 feet. Okay? And then the very last question. When will the ball be 20 feet high? Now remember, we're still using this equation right here. Every piece of this problem uses this equation. So I have an H and I have a T. And I have to fill in one or the other. So when will it be 20 feet high? Is the 20 going in for the H or is the 20 going in for the T? H. How do I know? 20 feet. Feet is not a time, right? So 20 equals -16t squared plus 32t. This is not so easy. What am I gonna do here? Jacob?
Set it equal to 0 by
Set
moving the 20 to the other side.
exactly. Move this guy over, because probably I'm gonna use the quadratic formula. This one may factor, I don't know, but I don't wanna mess with it. That would take even me a long time, and I'm the teacher. So I'm gonna use the quadratic formula on this. You can try to factor if you want. You can complete the square if you want, but it will have a fraction if you do that. Okay? So here we go. Let's use our quadratic formula and see what happens. T equals -b plus or minus the square root of b squared minus 4ac all over 2a. Does that look okay to everybody? Okay, we had a quiz one day where you had to complete the square, use the quadratic formula. Some of you didn't remember the quadratic formula, but then we had another quiz today. You had to do the quadratic formula. We have to do the quadratic formula on these problems. Do we need to know the quadratic formula? Yes. Okay, let's work on this under here. So I'm gonna go ahead and type it on my calculator. 32 squared minus 4 times -16 times negative 20 equals,
Negative 256.
and I got, oh, whoa, wait a minute.
Oh.
What does it mean when I have a negative under a radical? There's going to be an I in my answer. Now I just want you to stop. We're doing a word problem. The question is, when will it be 20 feet high? Never. Somebody said it. Never. Because can time be imaginary? No. Time can't be negative. We ran into that yesterday. Time can't be imaginary. In real world problems, we don't want imaginaries because imaginaries aren't real, right? So when does it reach never? Here's my picture of this problem. I don't know how high it goes, but up here's 20. It never gets that high. Yesterday, we had a situation and it was a different number, and it did get that high, remember? It got that high going up, and then it was also that high coming down. When we get an imaginary number, none, no answer. It doesn't get that high. Okay, all right, big deal. Let's put that away and let's get out our practice test now. And let's get started on that. So get out your packet. Congratulations, you made it through your first note packet. Practice test, anything I need to ask back in there. All right. You're all excited, we're doing our first practice test, everybody's pumped up, here we go. Who remembers? This is just everything all mixed up, guys. So who remembers our strategy when we had a problem full of fractions like this? Get the same denominator. Now, when we say get the same denominator, we mean all the denominators. So you don't see one over here, but there is one, right? It's a 1. And then they all gotta be what? What's gonna be the same denominator? 12. So this one is gonna get times by 3. This one is gonna get times by 4. And this one is gonna get times by 12. Okay, so here we go. Now, are they all 12 now?
Yes.
So I'm not gonna write them down anymore, I'm done with those. So 3x plus 9, distributive, minus 8x equals negative 36. You okay with that?
Yep.
These two are on the same side of the wall, so we add them together, negative 5x. Subtract 9. What is that, negative 45? Wow, this works out nice. Usually they don't. This comes out to the x equals 9. Everybody okay with that? Okay, now the problems are all mixed up. So now we've got an absolute value. All right, we talked about this relatively recently. What do we do with an absolute value?
Make 2 problems.
Make 2 problems out of it. So the first problem will be 2x minus 3 is greater than 4. Remember, for the first one, we don't change anything. We just drop out the absolute values. Don't change anything. For the second one, however, we turn the sign around and make the number negative. Remember that?
Yep.
This is a greater problem, so we're going to put an or in here. for greators, we always put ors. Less thans get ands. Now we solve each piece, so we'll add 3 and divide by 2. Add 3, divide by 2. Now I know there's a negative in this problem, but I'm not dividing by it. I'm dividing by 2, so that does not change. All right, let's look at it on the number line. Here's 7/2. If you wanna make that 3.5, you can. We talk about this all the time. I don't have a problem with the fraction. If you read 3.5, 3.5, great. Open circle shaded that way. -1/2 shaded
What?
this way. It's an or. So my answer is either this piece or it's that piece. How do I write that as an interval? You will need to write your answers as intervals. So how do I do that? What's this one? Negative infinity, -1/2. And won't they both be parentheses?
Yes.
Because this one is always, and this one is open. And I put my union symbol, parentheses, 7/2. Are we good? Now what have we got? What's C?
Quadratic.
It's a quadratic equation, which means I can use my quadratic formula. Now, if you happen to get an easy one, and you can see how it factors, then go ahead and factor it. If you happen to get a nice even one, ones with even numbers, and you wanna complete the square, go ahead. But this one, I think the very best thing to do is to do the quadratic formula. I think that's the easiest. Completing the square will always work, but I don't wanna do it, because I don't wanna divide by 3. So -b plus or minus the square root of b squared minus 4ac all over 2a. Now these are not big numbers. We should be able to tackle this one. What do we have underneath that radical? We have 49. Okay, this is a negative and a negative, so it's gonna become a plus. Right? What's 4 times 3? Times 2. Okay, that's easy. What's 49 plus 24? 73. Does 73 break down?
No.
No. So guess what? We're done. That's the answer.
Let's go.
Aren't we happy?
Very.
Hopefully you get one like that on your test. That doesn't break down and you don't have to do any weird stuff with it. Okay, that's problem 1. Yep.
I go to the bathroom.
Dude, you're getting out of school in 20 minutes. Can you hold it? No, Eddie, I'm serious. Can you hold it or not? If you can't, you gotta go. Okay, number 2. If the boys keep peeing on the floors in the restrooms, I don't wanna ever let any boy go to the bathroom again. They had to close that bathroom, it got so bad. Disgusting. All right, now we're switching gears, problem number 2. What am I gonna do with this?
Distribute the negative.
I'm gonna distribute the negative. Now, kids, this is not a FOIL. I know you see 2 parentheses, but it's not a FOIL because we only FOIL when the parentheses are right next to each other. If there's something in between the parentheses, it's a combined like terms problem. Got it? Do not FOIL. combine like terms. So what have I got? I've got 1 plus 3i. And that is it. Now, is this one a FOIL?
Yes.
Yes, because see how there's nothing in between? Okay, when there's nothing in between, it's a FOIL. Alright, so here we go. You did this on your quiz, hopefully correctly. 18 minus 12i plus 3i minus 2i squared. So FOIL, let's see if that's what you get. So, what do we remember? We just did this on our quiz. What do we remember? What happens down here?
I squared equals
That
negative 1.
becomes positive 2 because I squared is negative 1, so it changes that sign. That becomes positive 2. So 18 plus 2
20
is 20,
plus
and
9.
then negative 9i. How you doing on your tests so far? Not bad. Oh, now we got the killer section. What property? Are there any of these that you know?
Distribute.
Which one?
The A.
No, A is not distributive. C is distributive. C is absolutely distributive because look at the right side. If you multiply by 2, see what happens? That's a
Yeah.
distributive. So C is distributive. What's A? Guys, we practiced this. No, A is called the additive inverse. Because what happens when you add a 3x and a negative 3x? They cancel.
Zero.
When things cancel, it's an inverse. This one is an addition problem, so it's additive inverse. The multiplicative
So
inverse would be m times 1 over m. That's the multiplicative inverse because these two cancel each other out. What's B?
It's like the
Do
community.
you know, Xavier? Was your hand going up?
No, I was gonna ask when is our test.
When we're done with the practice test.
Would it be,
Your test will be when we get done going through the practice
Oh, okay.
test. So maybe 2 periods from now, maybe 3, just depends how long it takes us.
is this the one that it's like, there's 2 and it's like a slight difference between the 2? Like the
Well,
2, like, is
in-
it like commutative?
It's not commutative. Look
It's
at
the other
question
one?
B. What has to happen if it's commutative? What has to change?
Order.
The order, thank you. The order has to change. Look at the letters and numbers in B. 4xy, 4xy. Did the order change?
Mhm.
What changed? The way you associated them.
Associated.
The way you associated them, the way you grouped them. That is the associative property of multiplication. Because it's a multiply problem, and we associate it. You have a property practice sheet. We went through, I can't remember if we did the whole thing or just part of it,
Just check it out.
but the answers are in Schoology. The sheet's in Schoology. Practice if you want. Remember what I said? If it's on the practice, it's on your test. So there are 3 properties here. You're gonna have 3 of those questions on your test. All right, number 4. This one is a little bit tricky because factoring it requires you to remember something you learned last year,
Wait,
which you're supposed to remember anyway. But let's talk about this. Grant, what do you think?
You just like group them into 2 different.
So we call it factoring by grouping. So Grant says, let's look at these 2 right here. what can we take out of just those two?
X squared.
X squared. What do we have left if we take out an x squared?
X plus
X
4.
plus 4? Right? Now, what can we take out of these two? Be careful, what can we take out?
Negative 4.
A negative 4. You wanna take out that negative and a 4. Now, if you take out the negative 4, what do you have left? X plus 4. Remember, you took out the negative. This is awesome, because when you factor by grouping, what has to happen?
You get the same answer.
You got the same parentheses, right? That has to happen. If it doesn't, you factored wrong or it doesn't factor. Those have to match. So, I'm gonna write down the match. And then in another parentheses, I'm gonna write down everything else. Now notice, I wrote down the match. I didn't square it, I didn't write it twice, I just write down the match. And then in my second parentheses goes everything else that's left. So x squared minus 4. That we talked about yesterday. What is x squared minus 4?
X plus 4, X minus 4.
No, be careful, it's not 4. It'd be
Oh,
x
X plus 2.
plus 2, x minus 2. It's called the difference of
Squares.
squares. And remember yesterday I warned you, get used to that because it pops up all the time. This is the difference of squares, x minus 2, x plus 2. Now, this is not a number line problem because this is an equals. I only draw number lines when I have these things going on, because that means shading. If these equal 0, then what are my x values? X is gonna equal
Negative 4.
negative 4, positive 2, negative 2. That's it. There's no shading, there's no parentheses and brackets. It's an equals problem. And in an equals problem, it's x equals. We're gonna we'll practice again on the other practice tests. But if you're confused by that, come in and see me. We can sort through it, factoring by grouping. Now this is totally different. Problems are all mixed up. What do we do with something like this?
Square both sides.
Square both sides. And this is the kind where I'm going to have to check my answer. Remember, sometimes we got extraneous roots. So 3x minus 8 equals 36. So 3x equals, I add 8, gives me 44. So what is x equal? 44 thirds? You can tell this is a made-up Mrs. Ford problem. We got 44 thirds as our answer. Now, let's go back to the original problem. Don't panic. Don't panic. What happens when you put 44 thirds there? What's 3 times 44 thirds? What happens? So it's 44 minus 8, which is 36. And what's the square root of 36? 6. It checks. Now we have a problem we did yesterday. We're gonna do a few more, guys. Hang on.
Do we have to figure out if the other alternative works as well?
What do you mean the other alternative?
Because isn't it plus or minus 36?
No. When you square 6, 6 times 6 is 36.
Okay, yeah, I see.
It's only plus or minus when
Yeah.
square root.
We just test did these yesterday. I used to have a sign, Eddie, that said, "Time will pass, will you?" I hung it right up by the clock. I'm thinking of bringing it back. All right, what do you think? How do I do this problem? You did them yesterday. You don't have to dig back very far in that memory bank.
After.
Yep. Because we're gonna draw a number line. The number line is gonna have 2 dots on it. And those dots are either gonna be shaded between, or they're gonna be shaded out. Am I speaking a language you understand? I'm shade these out. I'm gonna shade in here. I'm gonna shade out here. But first I have to figure out where the dots are. So how does this factor? It has to multiply to give me 12, negative 12, but it has to add up to negative 4. Can you think of 2 numbers that multiply to give you negative 12 and add up to give you negative 4? Declan?
Negative 6 and 2.
Negative 6, positive 2. Which means your dots are at negative 2 and 6.
Yes.
I think we talked about this. If it's a greater than problem, where do we shade? Where are greater thans always shaded? Outside. Greater thans are outside. Greater than, far away. Great distance. So what's my answer?
Parentheses, negative infinity minus, comma, negative 6 brackets. Oh wait, sorry, 2.
Bracket?
Union.
Remember, it's the, my zeros, my dots, scout are the opposite of what's in here.
Yeah.
And so then I'll have 6 comma infinity. Is that right? All right, we got 1 page of the test done. Let's move on to the second page. We'll do problem, at least 5, maybe part of 6, and we'll be done. So here we go. What in the world is this problem asking me to do? Part A says, find this.
Distance.
What, that means distance. That means distance. The distance formula is the one with the big radical. And what's the distance formula say?
It's 2x minus x.
I subtract my x's, so 6 minus 1 squared, x minus x. I'm not doing slope, I'm doing distance. So x minus x squared plus 3 minus negative 2 squared. Okay? Hey, Kishad. Alright, so here we go. 6 minus 1 is 5, and 5 squared is 25. 3 minus negative 2 would be 5 again, right? Squared is another 25, so I have the square root of 50. Does 50 break down? Because if it does, we have to do it. It actually does break down because isn't 50, you can do it different ways, but isn't 50 5 times 10, which is 5 times 2?
5 root 2.
So the answer is 5 radical 2. That's exactly right. Because we have 2 5s and a leftover 2. All right, one more. and I'll stop. You've been good, real good, let's get through one more. Now we're doing midpoint. How do we find midpoint? How do we find midpoint?
Add them up and
Jacob?
divide by,
Oh, yeah, okay,
add them up and divide by two.
add them up and divide by 2. So we look at our x's, we add them up, 7 divided by 2. I am perfectly comfortable with 7 over 2, but if you wanna write 3.5 or something, I don't care. That's it, that's how you do it. Now, add up the y's. What do we get when we add our y's? 1 divide by 2, 1/2. And that is your midpoint. Okay? Alright, so my guess is, we're gonna have 2 more class periods, and then we're gonna have our test. So I don't know what day that works out to be, but 2 more class periods, and then our test. That's my best estimate. By the way, we finished P7, so P7 will be due on Tuesday. P7 due on Tuesday.
You read.